Determine the sum to n terms and hence the sum to infinity of the following series. Let us begin. So here we have a series whose first term is 1. Then we have the next term 3x. So here we have negative 3x added to 5x squared minus 7x cubed plus the rest of the terms. Now here, this is neither an arithmetic series nor a geometric series. It's not going to be an arithmetic series because here we do not have a fixed common difference. We can pick up any term in the sequence, and if we subtract this previous term from it, that is not going to remain the same. So that's why it's not an arithmetic series. Similarly, it's also not going to be a geometric series because it does not have a fixed common ratio. However, this particular series is composed of an arithmetic progression and a geometric progression. To extract that information, we're going to rewrite the given series as. So first, let's take the first term 1. We're going to rewrite it as 1 added to 1. Then added to it will be 3 multiplied to negative x added to 5 times x squared added to 7 times negative x cubed, and this is going to continue. Now, if we take the constant terms, that means if we take the first term is 1, the second term is 3, third term is 5, fourth term is 7, and this is going to continue, then this particular terms are going to be in arithmetic progression. They are in arithmetic progression. And if we consider the first term is 1, the next term is negative x, third term is x squared, fourth term is negative x cubed, then these terms are going to be in geometric progression. Fine. Now, here for the first term, we can easily define its nth term. The nth term is defined by the first term a added to n minus 1 times the common difference t. So here we have the first term as 1 and added to n minus 1 times the common difference, which is 2. When we simplify it, we're going to get 2n minus 1. Next, we have here the geometric progression where the first term, that's 1, the common ratio r, that's going to be negative x. We can pick up any term in the sequence, and when we divide it with the previous term, it's always going to give us negative x. So here, the nth term of the geometric sequence, that's given by a times r raised to the power of n minus 1, which means we have 1 multiplied to negative x raised to the power of n minus 1. We can furthermore simplify this as an equals to negative 1 raised to the power of n minus 1 multiplied to x raised to the power of n. So this is going to be the nth term of the geometric sequence. Now, the reason why we obtain the nth term of the arithmetic progression and the geometric progression, because this is going to help us define the nth term of the original series. Now, that is simply given by take the nth term of the arithmetic sequence, so that's 2n minus 1, multiply it with the nth term of the geometric sequence, which is negative 1 raised to the power of n minus 1, multiplied to x raised to the power of, this is actually n minus 1, x raised to the power of n minus 1. So this is going to be the nth term of the given series. We can verify that. So let's use a value. So let's say we try to find out the fourth term of the series. So if we substitute n equals to 4 in the nth term, so here a4, that's going to be equals to, we have 2 times 4, so that's 8. We have 8 minus 1 multiplied to negative 1 raised to the power of 4 minus 1, that's going to be 3. Multiplied to x raised to the power of 4 minus 1, so that's 3. And that's going to give us negative 7x cubed. And we see that's exactly the same as the fourth term of the series, which means we have obtain our nth term of the given series. So this particular series, which is composed of an arithmetic sequence and a geometric sequence, is referred to as the Arithmetico-Geometric Series. So now that we have the nth term, we are ready to find out its sum. For this, we will begin by first supposing that let Sn represents the Arithmetico-Geometric Series, where we have 1 minus 3x plus 5x squared minus 7x cubed all the way up to the second last term. Now, to find out the second last term, what we'll have to do, so here we have the last term, which is the nth term. So in the nth term, we're going to substitute n value with n minus 1. So that's going to give us the previous term. So we have 2n minus 3 multiplied to negative 1 raised to the power of n minus 2 times x raised to the power of n minus 2. Now here we need to be a little bit careful here. Now this is an oscillating series. Oscillating means that the sign is changing. So in the first term is positive, then the next term is negative, then the third term that's positive, and fourth term is becoming negative. This is an oscillating series where the sign changes. Now what we'll do, we will assume that this particular series has got odd number of terms. So whenever we have odd number of terms, then the last term is always going to be positive. We can verify that. So if we consider the original series 1 minus 3x plus 5x squared, so let's say there are only 3 terms. We have the first 3 terms, so 3 being an odd number, the third term that is positive. And if we have even number of terms, then the second term or the last term, so let's say 1 minus 3x, we are only considering the first 2 terms. 2 being an even number tells us that the second term is always going to be negative, or the last term of the series is always going to be negative. Now since we are considering odd number of terms, so this is going to help us simplify the problem. So we will consider the last term to be positive. We have odd number of terms, which means the second last term that's going to be negative in nature. So let's write down the last term. So that's 2n minus 1 multiplied to negative 1 raised to the power of n minus 1 times x raised to the power of n minus 1. Okay, so now that we have defined Sn, what we will do, we'll consider the common ratio of the geometric progression. We found out that the common ratio is given by negative x, so we'll take this common ratio and multiply it to the multiply to each and every terms of Sn. So that means we have negative x multiplied to Sn, which means that when 1 is multiplied to negative x, so that's going to give us negative x. Negative x multiplied to negative 3x, so that's going to give us positive 3x squared. Then we have negative 5x cubed. So this is going to continue till we reach the last term. So here, so when we multiply the second last term of Sn with negative x, we're going to get positive 2n minus 3 multiplied to negative 1 raised to the power of n minus 2 multiplied to x raised to the power of, now we have x multiplied with x raised to the power of n minus 2. So using the law of exponents, we can change it to x raised to the power of n minus 1. Then coming to the last term, we are going to multiply it with x. So that gives us negative 2n minus 1 times negative 1 raised to the power of n minus 1 times x raised to the power of n. Okay. Now here we are going to make a little change here. So that's a very crucial step here, so that we don't so that we can avoid any type of confusion later on. Now here we have in the second last term, we have 2n minus 3 multiplied to negative 1 raised to the power of n minus 2, but we can rewrite it as n minus 1 multiplied to negative 1 raised to the power of negative 1. Means exactly the same thing, but it's going to have a certain advantage. Multiply to x raised to the power of n minus 1. Now what is negative 1 raised to the power of negative 1? From the laws of exponents, negative 1 raised to the power of negative 1, that's equals to 1 over negative 1, and that's simply negative 1. Now that means this negative 1 raised to the power of negative 1 can be replaced with negative sign. So we get negative 2n minus 3 multiplied to negative 1 raised to the power of n minus 1 times x raised to the power of n minus 1. This can be also done to the last term as well. So here in the last term we have 2n minus 1 multiplied to negative 1 raised to the power of n minus 1 times x raised to the power of n. So here what we can do, we can rewrite negative 1 raised to the power of n minus 1 as, so we have 2n minus 1 times negative 1 raised to the power of n multiplied to negative 1 raised to the power of negative 1 times x raised to the power of n, such that this is going to now give us negative 2n minus 1 multiplied to negative 1 raised to the power of n times x raised to the power of n. And we're going to substitute this two values in the place of the second term and the last term. Now what we'll do, we will perform a subtraction. So we will take Sn, and from here we're going to subtract negative x Sn. That means we start on the right hand side, we'll start with 1. Now we're going to subtract negative x from negative 3x. So negative 3x minus negative x, that's going to give us negative 2x. Then add it to 5x squared minus 3x squared, so that's going to be positive 2x squared. Negative 7x cubed minus negative 5x cube gives us negative 2x cube added to. So this is going to continue. Now we're going to consider the last term of Sn and the second last term of negative x Sn. We are choosing in this particular fashion because here we can take x raised to the power of n minus 1 times negative 1 raised to the power of n minus 1 as the common factor. And once we subtract, we're going to get 2 multiplied to negative 1 raised to the power of n minus 1 times x raised to the power of n minus 1 minus the last term, which is going to be 2n minus 1 times negative 1 raised to the power of n times x raised to the power of n. And since the last term is coming out to be negative, which means its previous term was going to be positive. Now on the left hand side, what we have is Sn added to x times Sn. This is going to be equals to 1. Now what we'll do, we will take this second term all the way up to the second last term. So we have negative 2x added to 2x squared minus 2x cubed plus all the way up to the last term, which is 2 times negative 1 raised to the power of n minus 1 times x raised to the power of n minus 1 minus we have 2n minus 1 times negative 1 raised to the power of n times x raised to the power of n. The reason why we selected these particular terms, because this is going to be a geometric series where the first term a, that's negative 2x, the common ratio r, that's going to be negative x, and here we have n minus 1 number of terms. Now let's try to understand why there are n minus 1 number of terms and not n number of terms. Now when we perform the subtraction, we didn't use the first term of Sn and we also didn't use the last term of negative x Sn. So in Sn, if we know that there are total of n number of terms, and if we are excluding the first term, that means it's going to be left with only n minus 1 number of terms. Similarly, for negative x Sn, we considered the first term all the way up to the second last term and we excluded the last term here, which means that here also we have n minus 1 number of terms. Now while we're performing the subtraction, we considered n minus 1 terms of Sn and from here subtracted n minus 1 terms of negative x Sn. So that's going to leave us with n minus 1 number of terms. Now that we have a geometric series, we know there's a standard sum for finding the sum up to n terms. So that's given by the first term a multiplied to 1 minus the common ratio r raised to the power of the total number of terms n, provided there are n number of terms, divided by 1 minus r. So this is the general formula. We're going to apply this formula to find out the sum of the geometric series. So here on the left hand side, we have 1 plus x multiplied to Sn. That's going to be equals to 1 added to, so here we have negative 2x, that's the first term. To it we are going to multiply 1 minus the common ratio r, which is negative x, raised to the power of the total number of terms, so that's n minus 1, whole divided by, we have 1 minus the common ratio is negative x, minus we have 2n minus 1 multiplied to negative 1 raised to the power of n times x raised to the power of n. Further simplifying this, what we'll do, we're going to divide both sides with 1 plus x. So we have 1 over 1 plus x, negative 2x multiplied to 1 minus negative x raised to the power of n minus 1. This will be divided with 1 plus x and we're going to square this value. Minus, we have 2n minus 1 times negative 1 raised to the power of n times x raised to the power of n whole divided by 1 plus x. So this is going to be the sum to n terms of the Arithmetico-Geometric series, which is given by 1 minus 3x plus 5x squared minus 7x cubed all the way up to the n number of terms, or we can say nth term. Now that's the sum. But in our problem, we were asked that once we have the sum to nth term, we will also need to figure out the sum to infinite number of terms. Now let's put the condition here. So if the number of terms n approaches infinity, that means there are infinite number of terms n, we have a condition that the absolute value of x that's less than 1. Now absolute value of x less than 1 means the value of this is the common ratio. Actually the common ratio came out to be negative x. So when you take the absolute value of the common ratio, that's simply absolute value of negative x, which comes out to be positive x. Or we can say it's simply the absolute value of x. It has to be less than 1. This means that x, the common ratio, this should be something of the form where the numerator is less than the denominator. So we can have half, or we could have 2/5, whatever be the case, the numerator must be less than the denominator. Only in that case we can say that the magnitude of x, or the absolute value of x, is going to be less than 1. So this condition has to be met. Then what happens if x is less than 1 and n approaches infinity? Then x raised to the power of n, or x raised to the power of n minus 1, so they are going to approach 0. Also x raised to the power of n is going to approach 0. Fine, which means that s infinity, which is going to give us the sum to infinite number of terms, we have 1 over 1 plus x minus 2x multiplied to 1 minus. So here we have negative x raised to the power of n minus 1, which in other words is the same as saying we have 0. It's going to approach to 0, divided by 1 plus x whole square minus 2n minus 1 times negative 1 raised to the power of n times x raised to the power of n, so that's 0, divided by 1 plus x. Further simplification gives us s up to infinite number of terms, that's 1 over 1 plus x minus 2x over 1 plus x whole square. Now when we combine them, we're going to get 1 minus x whole divided by 1 plus x whole square. So this is going to be the sum to infinite terms of the arithmetico-geometric series, and we also have the sum to nth term.